Hello student, I am Dr. S.L. Munde, Assistant Professor, Department of Mathematics, Sri RLT College of Science, Akola. Dear student, in a previous lecture we have seen basic concept of index of a closed curve, or it is also known as a winding number. Then we have seen one theorem on index of a closed curve. So in this lecture we will see some problems on a index of a closed curve, or we can say that some problems on a winding number. So this problem may be asked in examination. So we will start problems on a index of a closed curve. So what is the title of the problems? Which types of problems will ask in examination? Using the index of a closed curve, evaluate the given integral. Okay, so these types of question may be the in your examination. Okay, so you have to evaluate this integral by using the index of a closed curve. So what is the problem? First, evaluate integral over gamma dz upon z minus a, where gamma of t equal to 2 e raised to power it, t lies between 0 to 2 pi. So this gamma of t, which represent a circle whose center is 0 and radius is 2, whose radius is 2. Okay, now we will see the solution. Given that integral over gamma dz upon z minus a, where gamma of t equal to 2 e raised to power it, t lies between 0 to 2 pi. Okay, so here the gamma is a curve which is anti-clockwise direction. Okay, so here if you observe that here the direction is not given. Okay, in previous lecture we have already seen if the direction is not given, then we can assume that the direction is in a uh, anti-clockwise direction. So here gamma is in anti-clockwise direction. Okay, so therefore index of a closed curve at a point A, so this is z minus a point, so this is the A point where A is 1. So index of a closed curve gamma at a point A equal to 1. Okay, because this one will inside the circle, because radius is 2, the point A will inside the circle, so therefore the index of a closed curve is 1. Okay, so therefore by using the definition of a index of a closed curve is given as integral over gamma dz upon z minus a equal to 2 pi I, index of a closed curve gamma at a point A. Okay, so put a equal to 1. Okay, 2 pi index of closed curve gamma n it of gamma of a, that is 1. So you will get integral over gamma dz upon z minus a equal to 2 pi I, and index of a closed curve at a point gamma at a point A, that is 1, so that is 2 pi. So therefore the value of this integral is 2 pi I. Okay, so this is the example, simple example on index of a closed curve. Now we will see a second example. We will turn one by one easy to hard example. Second example is evaluate integral over curve C twice z upon z square minus 1 dz, where C is a curve which is given as 2 e raised to power it, where t lies between 0 to 2 pi. Okay, now we will solve this integral. We will convert this integral in the simple form. So given integral is can be written as twice z upon z square minus 1 dz equal to, this can be written as a square minus b square, that is z minus 1 z plus 1. We can write in this way. Okay, so this integral can be written in this form. If you take the cross multiplication and multiplication, so after taking addition and subtraction, you will get twice z upon this term. Okay, that means you can say that this integral can be written in this form. Okay, now we will separate this integral. So integral over curve gamma over curve C, complex plane C, twice z upon z square minus 1 dz equal to first integral this and second integral this. So let us consider equation number 1. Now we will find out this integral and this integral. Okay, so if you observe here for this integral a is 1 and for this integral this can be written as in this way: z minus minus 1, that is a is minus 1. Okay, so here curve gamma, here curve C is in the anticlockwise direction. Here direction is not mentioned, so therefore we can consider the curve C is in the anticlockwise direction. Therefore, the index of a closed curve for this integral at a point A is 1. So we get 1 because the radius is 2. So if radius is 2, then this point A equal to 1, which is lies inside the circle where A is 1. And second, that is A equal to minus 1, this is also lies inside the circle because radius is 2. Okay. So here A is 1 and A equal to minus 1, both points lie inside the circle. Therefore, we can say that index of a closed curve for that integral is 1. Therefore, by using the definition of the index of a closed curve, and it is given as integral over gamma dz upon z minus a equal to 2 pi I into e of gamma a. Okay, so this can be read as index of a closed curve gamma at a point A. Okay, now we will put the values of this for a equal to 1 and a equal to minus 1. Okay, so by equation okay, so equation 1 becomes, so put the dz and value of a, so integral over c twice z, f of z is, that is twice z upon z square minus 1, z square minus 1 dz equal to 2 pi I index of closed curve C at a point A and plus 2 pi I. Okay, this C equal to minus 1 for this integral. So index of closed curve for this, that is 1 and that is also 1. Okay, so taking addition you will get 4 pi. Therefore the value of the integral over C twice z upon z square minus 1 dz equal to 4 pi I. So this is the complete solution of the given integral. Now we will solve third example. Okay, third example. What is the third example? Evaluate integral twice z upon z square plus 1 dz. Here curve is given as C, complex plane C, where C is 2 e raised to power I t, t lies between 0 to 2 pi. So which is represent a circle whose center is 0 and radius is 2. Okay. So given integral can be written as integral C twice z square plus 2 dz, okay, equal to, so this can be written in this form. So this can be written as z square minus under root minus z square minus under root 2 square. Okay, so we can write in this way. If you take the factor, if you solve this, you will get this term, or this term can be written as in this form. Okay, the factor of this term is z plus I under root 2 and z minus I under root 2. Okay, now this term can be written in this form. The calculation of this term, you will get this term. Okay, so this term can be written in this form for the easy calculation, for the easy to solve the given integral. So this can be written as integral C. First integral is dz z plus under root 2I, plus second integral is dz upon z minus under root 2I, equation number 1. Okay, so if you observe here, the curve is C, the direction is not mentioned here, so therefore here we can see that the curve C is in the anti-clockwise direction. Okay, so therefore the index of a closed curve for this first integral, that is where A is under root 2I, where A is minus under root 2I, okay, Z minus A, so A is minus under root 2I, okay, and for this A is under root 2I. So therefore index of a closed curve C at a point minus under root 2I equal to 1. Okay, so this under root minus 2 root I, which is lies inside the circle where radius is 2. Therefore it will give the 1, and index of closed curve for point root 2I, this will give 1. Okay, now putting these values in this integral, you will get the direct solution. Okay, so by using the definition of the index of a closed curve, so what is the index of a closed curve? Integral over gamma dz upon z minus a 2 pi index of a closed curve gamma at a point A. So here curve is given as C. So therefore index of closed curve C twice z, okay, divided by z square plus 2 dz, okay, equal to 2 pi I index of closed curve for first point and plus this is the index of closed curve for second point. So putting the values, you will get putting these values and these values, you will get 1 and here 1. So addition of both terms, you will get 2 pi. Okay. So this is the third example on a index of a closed curve. Okay. Now I will give you a third example, the fourth example on the basis of this. Okay. So you can solve this problem. Okay. Now we turn over the next example, that is find all possible values. Next example number 5. What is the example number 5? Find all possible values of integral or curve gamma dz upon z square plus 1 where gamma is a closed curve not passing through I and minus I. Okay. So here we have to find out the possible values of the integral. So what is given, that given integral is dz upon z square plus 1 can be written as integral over gamma dz z square minus I square. We can write in this way, minus into I square that is minus 1, minus 1 you will get that is plus 1, that is z square plus 1. So we can write this term in this way. Okay. The factor of this term can be written as z minus I z plus I by using formula a square minus b square. So this term can be written as in this way. Okay. So again this term can be written in this way. Okay. So if you take the cross multiplication and solve this term, so you will get this term. Okay. So this term can be expand in this in this way. Okay. Now multiply, separate this integral. You will get first integral is 1 upon 2i integral over gamma dz, first z minus I, and second integral is minus 1 upon 2i integral over gamma dz upon z plus I. Okay. But here gamma and the direction of gamma is not given, so therefore we can consider the gamma is in anticlockwise direction. Okay. Therefore, by using the definition of index of a closed curve, okay, so here gamma is closed curve not passing through the I and minus I. By using the definition of index of a closed curve, the index of closed curve gamma dz upon z square plus 1 2 pi I into index of closed curve n gamma of I. First for a equal to a equal to I and a equal to minus I, minus index of a closed curve gamma at a point minus I. So we can use definition here, index of a closed curve. Okay. So here 2 pi and this 2i 2 will get cancelled. So sorry, 2i will get cancelled, only remaining will be pi. So index of closed curve gamma at I, index of closed curve at minus I. Okay. But here the gamma is a closed curve which is not passing through the point I and minus I. Therefore there will be the 4 possibilities. Okay. So then equation 1 gives case number 1, if I and minus I are inside the closed curve. Okay, so there are the some possibilities. So first possibility will be, suppose that I and minus I which is lies inside the curve gamma, then the index of closed curve for this, that is 1 and that is 1. So 1 minus 1, that is 0. So this will become 0. Okay. Second case, if I and minus I are outside of the closed curve. Okay, suppose I and minus I both lies outside of the closed curve, outside of the closed curve. then the index of closed curve for that is 0. Index of closed curve for this 0. Okay, because this I and minus I both lies outside of the integral. If the point lies outside of the integral, then the index of a closed curve for that point will be the 0. So therefore by for this term 0 0, this will give 0. Third case number third, if I inside and minus I outside of the index of a closed curve gamma, then if the point inside the curve, then the value of that point is 1, and if the point is outside of the curve, then that value is 0. So therefore is 1 minus 0. So this is the 1 and this is the 0. Okay, so this can be written as pi 1 minus 0, which equal to pi. Second and last case is if I outside and minus I inside the closed curve gamma, then again here we will use here. So for this first point, the point I, which is like outside integral, therefore index of closed curve for that point is 0, and second point for a equal to minus I, the index of closed curve for that point is minus 1. Okay, so for this is 0 and for this term is 1. Okay, so therefore index of closed curve is pi 0 minus 1, so you will get minus pi. Okay, so these are the all the possibilities of the point I and minus I where gamma is not passing through the point I and minus I. Okay, so this is the complete example on a index of a closed curve. Okay, so here we have completed some problems on an index of a closed curve. Okay, so in next lecture we will see the another point on this topic.